In this video, we're going to look at adding and subtracting surds. Let's go back to a bit of algebra and look at collecting like terms. If I have 2p and I add to that 3p, we can collect like terms and write this as 5p. If I have, for example, now 3x minus y plus 2x minus 6y, we can go ahead and collect like terms. The x's are like terms and the y's are like terms. So 3x plus 2x will give me 5x. We've got minus 1y minus another 6y. That will give me minus 7y. So we could say that we simplified these expressions as 5p and 5x minus 7y. We can do exactly the same with surds. We can add and subtract like surds. So for example, if I have the root of a plus the root of a, this is simply going to give me 2 lots of the root of a. In the same way, if we had 5 root a minus 2 root a, we would have 3 root a. One advantage with surds is that we can make different surds into like surds by simplifying. So let's have a look at a basic example of that, and then we'll go on to some examples in addition and subtraction. So let's say I've got the root of 2 plus now the root of 8. Initially it looks like we can't add these together in the same way that we can't combine the x's and the y's, as they're not like terms. What we've seen in a previous video though is that we can write the root of 8 as 2 root 2. So what we have then is the root of 2 plus 2 lots of the root of 2. So if I've got now 1 lot of root 2 plus 2 lots of root 2, that gives me 3 lots of the root of 2. In the same way, if we had x plus 2x, this is going to give us 3x. It doesn't suddenly become 2 lots of 4. We're simply collecting like terms after we've simplified. So the root of 2 plus the root of 8 gives us now 3 root 2. If you want to check it on your calculator, you can just type it in and that will give you the value. Remember, these are going to be non-calculator examples as you're going to be tested on your ability to use the laws of surds. So 3 root 2 when it's simplified. So let's go ahead and look at some examples. We've got 1 lot of root 3 plus another lot of root 3. Well, that's simply going to give us 2 lots of the root of 3. It's not going to give us root 3 squared. It's not going to give us anything crazy like that. We simply add them and that gives us 2 root 3. In the same way that if we had x plus x, this doesn't suddenly become x squared or something crazy. It's just 2 lots of x. I've got now here 2 lots of the root of 5 plus 1 lot of the root of 5. All I'm going to have now is 3 lots of the root of 5. So 3 root 5. Here I've got now 7 root 3 minus 2 root 3. These are like surds. So we've got now 5 lots of the root of 3. Root 2 plus root 8, which we've just seen, will give us now root 2 plus 2 root 2. So let's just write this out. So we've got root 2 plus 2 root 2. So that's going to give us now 3 lots of the root of 2. Make sure you're showing workings. Okay, this one right here, now we've got the root of 50 plus 3 root 5. We've seen that the root of 50 can be written as the root of 25 times by 2, which is going to give us 5 root 2. We're trying to add to this 3 root 5. We can't do it as they're not like surds. We can't do any further manipulation, so we'd simply write this now as 5 root 2 plus 3 root 5. It's important to understand that we can't combine these. These are both prime numbers. We're not going to simplify further. Okay, let's look at this one here. Root of 27 plus 2 root 3 minus root 12. All I'm going to do is use my understanding from the first video to rewrite these. If you're not happy with rewriting them, go back to the first video and it should make sense. The root of 27 is going to give us 3 root 3. We've then got plus 2 root 3. We saw that the root of 12 could be simplified now to 2 root 3. These two are going to cancel, so we're simply going to have now on here 3, let's just put that in, 3 root 3. If you want to check it on a calculator, if you're in the infancy of your work, just pop it in, root 27, then we're going to have plus 2 root 3, and then we're going to have minus root 12. So all of these simplified now to multiples of the root of 3, and if I just type that in, we get the answer there. Don't decimalize the answer and truncate it, we leave it as an exact surd. Remember, the exact value is written as a surd. Okay, this one is a bit of an extension one, but we'll have a go at it anyway. The root of a plus 3 lots of the root of 4a squared minus 5 lots of the root of a times by a. So let's just consider each of these as we go. So what we've got here is the root of a. We'll just leave that as it is. Plus what we've got now, and I'll split this up. What we're going to have is, and I'll do it step by step, we're going to have 3 lots of the root of 4 times by the root of a squared, minus now what we've got here is 5 lots now of the root of a squared. The root of a squared is just a, and a few different approaches with this. I'll do it step by step so you can see what I'm doing. What we've got is the root of a. This is going to give me now plus 6, and we're going to have, because the square root of 4 is 2, 3 times 2, and then we're going to have a, and then this is going to be minus now 5a. So all I'm doing is writing it step by step. So we could say that this is going to be the root of a, and then we're going to have on here plus a. That is left now in the simplest form. You could argue, if you wanted, that you could factor this, and if you know the rules of indices, you might want to go ahead and factor it. I'm going to factor it, but see this as a bit of an extension. So using powers, we saw that the root of a was a to the 1/2 power. So I could write this now as a to the 1/2 plus a to the first. The highest common factor is a to the 1/2, so we'd have a to the 1/2, and then we'd have now 1 plus a to the 1/2. Or if you like, you could write this as now the root of a 1 plus the root of a. So if you had a really nasty exam question and it said show that this could be written in this particular form, then what we could do is write it like so. So there we go, adding and subtracting surds. We can add and subtract like surds, but we can also manipulate surds to make them like surds and then carry out the process. So if we've got the root of a plus the root of a, it's 2 root a. If we have 5 root a minus root a, it's 4 root a.